Alright, in this lesson we're going to talk about circle milling a hole in a part. Okay, so I have drawn a 2-inch diameter hole. We're going to use a 1/2-inch end mill, and if the toolpath was posted out by a CAD system, then this is the toolpath that you would be looking at. You can see the angled approach, then radius in on the lead in, and then we make our way all the way around, and at the top of the circle it gently comes back out of the cut as a radius move, and then a linear move back to center. So if this was a finished pass, you would activate the G41 code on the straight leg in, radius all the way around, lead out with the radius, and on this last move here back to the center, that would be a straight line move, you do a G40 cancel cutter comp. Alright, so if I play that toolpath one more time, I want you to notice something about the toolpath itself. When we're doing toolpaths on the outside of a part, I told you if you want to climb cut, to always pick your toolpath in a clockwise motion, but I want you to notice that when you're on the ID, in order to climb cut, we're going to have to do a counterclockwise toolpath. Okay, so I want you to remember, any toolpaths you pick on the outside of a part is going to be in a clockwise motion to make sure that you're climb milling, and then any features that you mill on the inside, whether that be a square, rectangular or circular pocket, you will always pick the geometry in a counterclockwise motion to always make sure that we are climb milling. So outside clockwise, inside counterclockwise. So if we're going to handwrite a program to do a circle milling operation, then I would not suggest to come in at an angle and an arc in. That would take too much math to figure out those angles and lead-ins and all that. So what I recommend is that we make a straight move to activate our cutter comp. Then we do a small lead-in radius. We do our complete circle. And then when we get back to the top of the circle, do a small lead-out radius, and then a straight move back to center. So this is what the toolpath would look like. Lead in, all the way around, and then a radius lead out. And the reason for the radius lead in and lead out is so that we won't put a ding in the part or a mismatch right here. What happens is when the tool comes in and stops up against that wall to change direction to make that radius, it actually puts a little ding in the wall, and then when it comes all the way around, it has to change directions abruptly again. So the tool actually stops, puts another ding on your part before it comes back to center. So it's best to lead in with a straight line move, arc in, all the way around, and arc out, and then back to center. So let's talk about a strategy on how to create that toolpath. Alright, so for this example, we're going to be milling a 3-inch circle. Okay, we're going to be using a 1/2-inch end mill, and what I suggest you do is when you handwrite the code, that you actually draw with dotted lines your toolpath that you're going to be finding the coordinates to. Okay, so notice if I'm using a 1/2-inch end mill, then the center line of my tool is actually a 1/2 inch smaller than the actual hole diameter. Okay, so that is going to be the center line of my tool. That's offset a 1/4 inch, but it's a 1/2 inch smaller on the diameter. Then the lead in and the lead out move, I want you to make half the diameter of your tool. So what we do is we come from the center. The center of the hole will be x0, y0. We make a straight line move to the bottom of that circle. Then we use the right side of the circle to lead in. Then we come all the way around. And then we use the left side of that 250 circle to arc out, back to that straight line move and back to x0, y0. So let's talk about the G code we would use for each move. Alright, so from the center to the bottom of the lead-in move, we're going to use a G1. Then the lead-in move is going to be a counterclockwise arc to the top of that radius. Then a G3 move all the way around, then back to the top. A G3 move coming off the circle as a lead-out move. And then a G1 back to center. So now let's put some coordinates to that. Alright, so let's take a look at the X and Y coordinates of this toolpath. And there's only 3 coordinates that we are really dealing with. The one in the center where we start, the one that's the start point of the lead in, which is also the end point of the lead out. Then we have where we engage into the part and also where we lead out of the part. So let's take a look at the code right here in the bottom right. We start in the middle at x0, y0. Our first move is a G1Y 1 inch. That puts us right there at the bottom of our lead-in move. Then we do a G3, and the G3 gets us up against our part. So that's a counterclockwise move to the Y 1 inch 250, which puts us up against our wall. And then we have a J value of 0.125, which is the distance to the center point of the radius we're swinging, measured in a plus direction from our start point of the radius. Okay, so we're sitting at Y 1 inch. We're going to G3 Y 1 inch 250 with a radius of 125, which the center point of that radius is 125 thousandths away in the plus direction to the center line of that radius. Then all we have to do to make a complete circle is called a J minus 1 inch 250. And what does that mean? We are still in a G3 mode. Remember, that stays modal, so we don't have to call it again. So actually it says do a G3, do a counterclockwise arc. The center of that arc from where you're starting is 1 inch 250 in the minus direction. So it's that same x0, y0 point that is actually the center of that radius. Okay? So it completes that move. We're sitting back at the top of the circle, ready to do a lead out move. And the lead out move is going to go back to that Y 1 inch. So because Y was modal on this J minus 1 inch 250, now that it changes, we have to call it what it is. So we're going to do a G3 Y 1 inch. Okay. And from where we start, the center point of the radius we're getting ready to swing is in a minus 0.125 thousandths distance. So then we sit at the bottom of our lead out move, and then we're going to do a straight line back to the center. So we have to make sure to call a G1, and we're back to x0, y0. So that is all the code that we need to do a lead in, lead out, and a complete circle. Alright, so let's take a look and see what this looks like at the machine. We're just going to go 20 thousandths below the service. There's that straight line move, arc in. Then this is the line where all we have is a J minus 1 inch 250. And that command alone makes a complete circle. The machine knows what to do with that. We come back to the top of the circle. We arc out. And a G1 back to center where we cancel our cutter comp. So now that is just one complete circle we did. If we actually double up on that J minus 1 inch 250, it will actually do 2 complete circles. So let's take a look at that. Alright, so it starts out just like the previous cycle. We come in with a straight line move, we arc in. We come all the way around, and notice in the program we're sitting at J minus 1 inch 250. So on that line, the machine knows to go all the way around. And then once it gets back to the top, it's going to read another J minus 1 inch 250. So it's just going to do another complete circle. Alright? And so that is actually doing a spring pass. So if you were deeper in a hole or in a pocket, you would have a better chance of getting a good finish. Then our lead out and back to center. Alright, so your exercise will be to write a toolpath for a circle milling operation to mill this 3-inch diameter using a 5/8 diameter end mill. And I want you to make 2 passes all the way around before you come back to center. Write a complete program in GWizard Editor and make sure it runs without any errors. Good luck.